Good morning, everyone. I'm going to go through 10J question 5. In particular, I'm going to look at the second part, which is finding the second derivatives here. Just a quick few notes on the other parts of this question, though. For part I, when it says find the local maximum or minimum points, you could use your GDC for this, or of course you could set your derivative dy dx is equal to 0 and then solve that. You can use whichever technique is quicker. I'd probably try to keep doing things algebraically at the moment, just to get a lot of practice with that, if it's possible. Okay, so that's finding the local maximum or minimum point. If there was a condition on, say, for example, on this one here, and they said, well, actually, the limits of this are between x is 0 and x is 5, then you might need to check the two ends of that as well for the local maximum or minimum point. So, for example, this, if it's the end of the function, would be a local minimum, as well as this being a local minimum. Okay, but it doesn't, so we won't do that. I'm going to do the second part in a moment, and the third part is find any points of inflection. Well, once we've got this function here, we can set that equal to 0, and then we can either try to solve it algebraically, or again, we can use nsolve on our calculators. So I'm not going to do that part of the question. And for the last part, is determine the intervals where the function is concave upwards and where it's concave downwards. So that's a matter of saying, well, when it's concave upwards, we know that the gradient is increasing. So strong negative, negative, 0, positive, stronger positive. So it's increasing from left to right. So where it's concave upwards, you say what you find dy dx, sorry, second derivative, d squared y dx squared, and you're looking for where you get values for x, because this will be a function of x here. We're looking for where those values of x are going to be greater than 0, because then you'll have an increasing function from left to right. Okay, right. So I'm just going to do the second parts of these questions. So let's look at this question here. Now, for part A, there's two ways of doing this. You can either expand the first bracket, so you can expand x minus 2 cubed. Perhaps you want to do that by doing x squared and then times by x minus 2. And if you wanted to do that by, for example, you could do x squared minus 4x plus 4, and then times that by x minus 2. You should end up with 6 terms here, and you can simplify those 6 terms to get the answer to this, and then you can times by this thing here. That's one way of doing it. I'm actually going to choose the product rule way of doing this one. So for this question, we say, well, u is equal to x minus 2 cubed, and v is equal to x plus 1. Now, because the derivative, we need to use the chain rule here, but because the derivative of what's inside is 1, then we just need to times the outside by 1 as well. So that's not going to change anything on the outside. So we can just treat that like normal, take the 3 to the front and then reduce the power by 1. For v dash, we're getting 1 for this one as well. So when we do u v dash plus v u dash, you're getting x minus 2 cubed times by 1 plus, and v is x minus 1, x plus 1, and u dash is, we'll put that 3 at the front there, and x minus 2 squared. Okay, then that's the first derivative, so we can call that one dy dx. If we're looking for the second derivative, we'll need to do that process again. Now, you're going to use the chain rule with this part, and you can use the product rule with this part here. So chain rule with the first part is going to be equal to 3x minus 2 squared, just like before. And then let's do the second bit up here. But u is equal to 3x plus 1, and v is equal to x minus 2 squared. So we can use the product rule for this. We could have left the 3 outside, by the way, and then just keep that as a factor of everything. But I think it's easier perhaps with using it one of the functions. Okay, so if you multiply this one out, then you'd get a linear function, and the derivative of that would just be 3. And then v dash in this case is going to equal to 2x minus 2. And again, you could multiply this out and do this one. But again, we can see that the derivative, using the chain rule, the derivative of what's inside is just 1. So there we go. Now we do u v dash plus u v dash, sorry, plus vu dash, vu dash. Okay, and u in this case is 3x plus 1. V dash is 2, so let me put a 6 in front there. 2x minus 2, and then v is equal to x minus 2 squared, and v dash, sorry, u dash is equal to 3, so I need to put a 3 in front of it. Now this can go over here. Okay, so we're getting plus 6x plus 1 x minus 2 plus 3x minus 2 squared. Okay, now this one can obviously be simplified. I'd probably just multiply that one out just now. You may be able to do some clever factorization though. So you can multiply it out and simplify it. We can see that we've got this thing twice, so that's 6. Let's just simplify that to start off with. 6x minus 2 squared plus 6 plus 1 x minus 2. Now I'm going to factorize out x minus 2 because I see it in both the expressions. Factorize out the 6 as well. And then inside the brackets, you're going to get another x minus 2 and plus x plus 1. Okay, and if you simplify this, you get 2x minus 1, which is what the answer gives you as well. Okay, let me do one more question. I might only do one because I'm meant to be online to actually see you in the meeting in a second. So let's do the second one of these. Okay, so let's do H. So here we can see we've got a product of functions here. Interestingly as well, they give you a range of values here. So you might need to check, as I said earlier on, might need to check both ends of this because again, it could be that your first value is also a minimum, a local minimum, for example, and possibly your last value is a local maximum as well. So you might need to check other things other than the turning point. Okay, so let's just say we've got u equals e to the minus x, and we have v is equal to cos of x, and so v dash is equal to, what do we got? We've got minus sine of x, and u dash is equal to minus e to the minus x. That's just using the chain rule there. We're saying e to the x or e to the u becomes e to the u, and the derivative of what's inside is minus 1, so we can times by that as well. So we're then saying u v dash plus v u dash is equal to e to the minus x. V dash is minus sine x, just put the minus outside the front, plus, and v is equal to cos x, and then u dash is equal to minus, so let's just put that first, the minus e to the minus x, and then that was u dash, and then v is equal to cos of x. And you can see that this one, you could factorize out your minus e to the minus x there if you wanted to, and then you'd be left in with sine x plus cos x. But it depends on what you want to do here, because this version you could use the product rule twice with, or this version you can use the product rule once with. So I think actually I'll use the second one because we need to do this differentiation again. So that's your dy dx. Okay, so for the second part here, we'll say u is equal to minus e to the minus x, and v is equal to sine x plus cos x. Okay, so we've got u dash here is equal to e to the minus x. That's me just saying e to the u becomes e to the u, but then the derivative of what's inside is minus 1, so let's times by the minus 1, and we get e to the minus x. If you want to do that more in a more extended approach using the chain rule, then please, by all means, do so. Right, and v dash in this case is going to be cos x minus sine x. Minus sine x here. Okay, so then let's put this together. We've got u v dash plus v dash. So we've got minus e minus x. V dash was cos x minus sine x. And then we've also got plus v and then u dash. So plus e, I'm going to put u dash first, e to the minus x. And then we've got v, which was sine x plus cos x, right? Now you can obviously multiply this out and you can simplify. I'm just going to skip a step here. I can see, what have I got? I've got cos x times by e to the minus x and cos x times e to the minus x there. One is plus and one is minus, so the cos essentially is going to cancel out. And then I've got minus and a minus times it together to give a plus e to the minus x sine x, and I've got that a second time here as well. So I know that my answer is going to be 2 e to the minus x sine x. Okay, so there's your final answer, and that checks with what we get in the book as well. Guys, I'm going to stop there because I'm going to go live on the meet now, but thank you for listening in. If you want me to go through anything else, then please do speak to me or post up